Today we will be discussing how polymorphic warnings reduce habituation in the brain. Insights from an fMRI study. This paper was written by Bonnie Brinton Anderson, C. Brock Kerwin, Jeffrey L. Jenkins, David Ergel, Seth Howard, and Anthony Vance. So, let's get started. As IT security technology gets better, hackers are focusing less on attacking computers and more on attacking the users of the computers. Users of computers do things which aren't the best for their security, like creating bad passwords, giving out personal information, and not responding to security warnings right. End users often ignore important security warnings when using computers because warnings occur so many times, so users grow used to them. The purpose of this study is to see how people process warnings they have seen a lot and whether the use of changing or polymorphic warnings can make people less tired of seeing the same old warnings. Other studies have shown that users of computers may not be as secure as they should be. Users click through 50% of SSL warnings, warnings that mean a website may not be safe to use, in only 1.7 seconds. Only 14% of participants in one study were able to recognize changes in the words of confirmation warnings. Additionally, neural research done on sea slugs has shown that reactions decreased after repeated exposure to a situation in a process called habituation. Habituation means, in short, the more often you are exposed to a situation, the less your brain responds to the situation. So the theory here is that the more people are exposed to security warnings, the less people respond or even pay attention to them. In this research article, the researchers thought that introducing polymorphic warnings, or warnings that change, would reduce habituation in users, essentially making users get used to the warnings slower. In other words, changing up security warnings should make users more likely to pay attention to them. They also thought that polymorphic warnings, warnings that change, will cause higher responses in the visual parts of the brain than warnings that don't change. The researchers set out to test these ideas using fMRI scans of individuals being shown both static and polymorphic warnings. For this study, participants were asked to spend about 45 minutes in an fMRI machine. While in the fMRI machine, each participant was shown images one at a time from a pool of 560 images, 40 of which were warning images. Both changing and unchanging warnings were shown 13 times to each participant over the course of the experiment. Some examples of polymorphic warnings included changing the color of the text in the warning, adding pictures, and animating the warning by twirling, zooming, or jiggling the warning. Each image was shown for 3 seconds each, with half a second between images. In a companion experiment, participants were asked to download software that allowed the researchers to track the participants' mouse movement. The participants were then asked to download 20 different kinds of weather software, and they were asked for permission each time they downloaded the software so that the participants would become habituated, or would get used to, the warning. However, one group was shown warnings that include the most effective of the polymorphic or changing warnings from the previous experiment, while others were shown warnings that did not change. The results of the first experiment did indeed show that those who were exposed to polymorphic warnings, warnings that changed, had higher visual responses, and therefore were less habituated to the images. So, if warnings change, people are more likely to look at them and process them. Therefore, users don't get as used to warnings that change. The second experiment supported the results of the first, showing that those who are exposed to polymorphic warnings, warnings that change, took more time to click through the warnings. Though a great experiment showing how people get used to warnings and how to prevent that from happening, there are some limitations. First, these were lab experiments, so the researchers didn't necessarily show that this works in real-world environments. They also didn't measure whether people ignored the warnings, so we don't know for sure yet if warnings that change actually make people more likely to follow warnings. This study has broad implications for the IT industry as a whole. First, IT security warnings should be shown only when needed. If security warnings are shown over and over and over again, people become used to them and stop paying attention to them, even though they may be important. Second, polymorphic security warnings, or warnings that change, help users to pay more attention to warnings. So if a company like Google is worried that people aren't paying attention to unsecure website warnings, it could change the warning each time it is shown so that people don't become used to the warning. Finally, this study suggests that other changes in warning design could also be effective in helping users to better heed security warnings. Overall, this study can help the IT industry to become more secure and help users to engage in better security behaviors. Thank you for your time. This has been Nathan Burton presenting the research article, How Polymorphic Warnings Reduce Habituation in the Brain, Insights from an fMRI Study by Drs. Anderson, Kerwin, Jenkins, Ergel, Howard, and Vance.